The topic for today, guys, I'm going to write it in here, is solving linear inequalities. You remember about the inequalities in the second portion. Inequalities. So only that in this case, we need to solve using inequalities, not only the equations that we were using in the system of equations, we are going to use inequalities in this part. So in the example 1, we need to identify solutions of inequalities. So in the example 1, we have identifying solutions of inequalities. Okay, then in the theory we have at the top of the page, a linear inequality is similar to a linear equation, but the equal sign is replaced with an inequality symbol. Remember, less than, greater than, less or equal, greater on, equal. So a solution of a linear inequality is any ordered pair that makes the inequality true. We have in this 4 examples, so I think that maybe today we can solve the first one and the second one. We have this, the order pair 7, 3, and the inequality is this one. The inequality we have is y equal, but it's not equal. Remember, it's an inequality, so I'm trying to compare it with the equation, okay? With the equations we had in the other one. So you can see x minus 1. Remember that in the last topic we were studying, for example, you have something like this. You have the equal. The only difference in this part is that y is not completely equal to this value. They are giving you the information that y has a value that is less than this one, okay? X minus 1. So when we evaluate, the only thing that is going to change is the sign of this. This is a, okay, this. Okay. We can make a table. Remember, we can work in order. If we represent this in a table like they write on the book, we have that y is less than x minus 1. And what are we going to do? We are going to replace the values for the x and for the y. So I replace the value for the 7 and for the 3. What do we have in here? Y, what is the value for y? 3, right? So I replace 3 is less than the value for x. The value for x is the 7. Remember that the value for x is the first value that I have, okay? 7.
Mister,
Tell me.
dice Diego que Zoom lo sacó, entonces que si lo podría usted volver a aceptar.
Okay, I'm going to accept him. On the waiting room. Yes, he is on the waiting room. Then we have this. Then guys, I only replace the value that we have for each one of the variables. Remember when we started with the system of equations, they give you some values and you need to prove these values to identify if they were the solution for the system of equations. In this case, it's completely similar. They give you an ordered pair and they ask you to prove if this is a solution, but in this case, it's not an equation, it's an inequality, okay? So needs to fit in this condition, that this value, 3, is going to be less than 7 minus 1. And it's true. Yes, right? Because 3 is going to be always less than 6. So that's what you prove. You can say that this is correct. So we can say, like in the system of equation, that the order pair 7, 3 is a solution. Remember that after we prove this, after we try the values in the inequality, we need to say if it's an equation or not. In this case, a solution for the inequality, okay? So we prove and we write that it's a solution, okay? So again, for the example 2, not the example 2, it's the same example 1, only that the inside is B, okay? But it's going to be completely similar. I'm going to write A in this one, okay? So you can see the difference. Okay, so for the first one, the order pair is 4, 5. And the inequality y is greater than 3x plus 2. In some of these inequalities, you are going to find this greater or equal. In the other one, the same. You can obtain less than or equal to, okay? It's the same. You are going to keep the sign of the inequality and you only check if they fit in the condition, okay? So for the first part, we substitute the values. X is 4, so I'm going to replace the x in the value that is multiplying the number 3. And for y, we are going to replace the value that is the number 5. So 5 for y is greater than 3x. What is the value for x? 4 plus 2. So since the moment you see something like this, it's going to be a solution. No, right? Because 5 is never going to be greater than 12 plus 2. You have that 5 is greater than 14. That's not correct. 5 couldn't be greater than this number. So we can say that the order pair is not a solution. So the order pair 4, 5 is not a solution. Solution, okay. We try the values in the inequality, and if we say that it's a solution, we write it. If it's not a solution, we write it again. It's not a solution, okay? So now we go to the example 2. Okay, in this part, we need to graph the linear inequalities. So we need to graph, and we are going to determine something. Graphing linear inequalities. Example 2. Graphing linear inequalities. And what we have some theory. In the step 1, we solve the inequality for y. In these cases, they give you the inequality solved for y. When the value of y is the first that appears, it's because they solve for the value, or because you can see that any value is multiplying or dividing the y. So the variable is isolated, you can work with that, okay? So step 1, solve for y. Step 2, graph the boundary line. Use a solid line for greater than, less than, greater or equal, less or equal, okay? All these symbols for the inequalities, depending on the symbol you need, okay? And the symbol they give you on the inequality. Step 3 is shade the half plane above the line for y, or for, in this case, greater than, and the other part is greater than or equal to. Or shade the half plane below the line for y less than, or y less than or equal to, and we check the answer. So for example, the number 2, graphing linear inequalities in 2 variables. We need to graph this, the solutions of each linear inequality. So if I write the A, y is less than 3x plus 4, The inequality is already solved for y. You can see that the value for y is isolated. We don't have any number multiplying or dividing y, so it's isolated. We can continue solving this. Graph the boundary line. So we graph the equation. To represent this is called the boundary line, okay? We represent the part of the graph that we are going to use. So you graph this. You already know how to graph. We start with 0 for x, and you obtain the value for y. And again, 0 for y, and you obtain one value for x. That are the intercepts. They are the intercepts, sorry. And then we graph the line to see in what part are we going to work. Then maybe I can represent with you only using this, okay? We don't need too much, only to understand the graph. You have this part, okay? And you have this line. I'm going to represent this line using another color. For this one, imagine that you have something like this, okay? The important thing that I'm going to tell you is that you have y is less than 3x plus 4. Look that the y-intercept has to be in 4. So maybe I can move. Okay, imagine that in here is the 4 for y. I can write the 4 in here. Okay, this is the intercept, y-intercept. We have the negative values for x in here, and we have the negative values for y below. So what part of the graph I'm going to take? All the parts that are below the line, okay? The parts below the line. The inequality is less than, so we shade this part, okay? All this part you color, okay? This is the part that you have for the inequality. All the things that are below the line. If it's a greater than, then we are going to take this area, okay? The area that is above, the area that is over this part. In this case, again, it's less than, so I'm going to select this. They color, okay? Only that I don't have how to color this part. But this is the idea. You take all the parts that are below. And for the other one, for example, I'm going to copy the other one. The other one that we have is 3x plus 2y. This is greater than or equal to. I'm going to write it in this way because on the laptop I don't have the symbol to write it complete with the line, okay? So greater than or equal to 6. And I need to isolate for the variable y. So then we have that 2y is greater than or equal to. The values that we have to replace is the 3x is going to be negative plus 6. And later the number 2 that is multiplying, you pass it to divide. So you have that y is greater than or equal to negative 3 over 2x plus 6 divided by 2, that is going to be 3. So that's what we have, right? Yes, that's what we have on the graph. Okay, so again, if I draw for you this line, I draw this part too. In the line, you represent negative 3 over 2x plus 3. You represent the line, the intercept is in 3. You have something like this. And what is going to happen later? What is the area I'm going to take? I'm going to take the area above because this is greater than or equal to. So greater than, so you take the area that is above the graph, okay? This part is what you are going to take. I cannot color again, only that I'm showing you using the lines. Maybe you can understand what is representing this part, okay? I color the part that it's above. We can check the values in the voltage check. With the inequality, they replace for the value of x is 0 in this case, and later with the other value for y. And you can see if the statement is true or not, okay? That's the idea, to check if the solution that you have is going to be correct. So you can see that in the part below, they write a false statement means that the half plane containing 0, 0 should not be shaded. So it's not one of the solutions, so the graph is shaded correctly. We try with the values for x0 and y0. Remember that they are the intercepts to check for the origin, okay? So if, for example, if the statement is correct, it's because I underline or I paint the part that wasn't correct. If the graph includes 0, 0, I need to take the part below too. But in this case, you can see that we don't include it. We are taking only the part that has greater than or equal to, okay? So the values greater. So in this case, this is all for the second example. In the number 3, we only have some theory about the consumer economics application, one application, and writing an inequality from a graph, okay? So the most important is the number 4, I think. The number 4, we can complete this, okay? And so, again, with this part, for example, in the first one, we only identify if this is a solution. So we try with the values they give you. We replace for the values of x and y to prove this is a solution, because you need to prove the condition they give you. For example, in this case, it's less than. So you need to have that the value for y, that is 3, has to be less than the value you have for x minus 1. So you prove it in this case, and you obtain that the statement is true. The same you have in this. This is the one that you want that you have the question, okay? I think. Okay.
Yes.
Graphing linear inequalities is the same. I have the inequality y less than 3x plus 4. So you need to fit this inequality, okay? You need to fit this condition. The values you are going to take have to be less than this value. So the values less, you are going to take the values below the graph. This line is the graph. Only that in this part, I don't write the point for the arrow. I don't draw the point for the arrow, but it's this part, okay? You have the graph and you take the values that are below your graph. All this part you can take, okay? To fit this condition. And for the other one, for example, the second, 3x plus 2y is going to be greater than or equal to 6. So if you have the symbol greater than, it means that you are going to take the values that are above the graph, okay? You are going to take the values that are over on the top of the graph, okay? This part. We don't include the values that we have below. It's the opposite of the first one, okay? Can you see? It's the opposite because in this one, we take the values that are down, and in this one, we are up, okay? We are taking the values above the graph. So I don't know if it's that's your question about the theory of this. You can see that in the rules they give you, graphing linear inequalities, they show you 3 steps, step 1, 2, and 3. So, and they told you in the step 2, what lines to dash if it's less than, and in the 3, they told you what to take if it's greater than. So that's the only thing, okay? Only to represent the inequality. And this in the equation you represent it in the same way that we graph the equations, okay? We graph and later we represent only, okay? So I'm going to finish in here, guys.